Hello, my friends. Mrs. McBride here, and we're on to our next topic, and we're really on to our next course, which means that everything that we've already talked about, you'll never be assessed on again. Now, will I ask you to remember some of it? Sure, it might be applicable, but a lot of that stuff is in the old course. We're moving on to the topic of waves, which is, I think, a really cool topic, and we're going to talk mostly about sound waves and light waves, but we'll hit a bunch of different types of waves in addition to that. Some people like waves because if you don't like a lot of math, then you're in luck. Some people don't like the topic of waves because there's not a lot of math. So there's a bunch of vocabulary words and things like that. So here we go. So I'm in our new waves packet, and I'm on to page 2. So before we really get too far into this, it'd probably be a good idea to define what a wave is. A wave is a rhythmic disturbance that carries energy through space. Now you'll notice that waves don't carry matter, okay? Meaning that waves don't have mass. They just carry energy. So if I was to get real close to you and yell real loud, "Hey, do waves carry matter?" And I was to say that really loud, it's not like you would feel tiny little particles hitting your body as my wave was hitting your body, right? Like little collisions. Think of like being shot with a paintball or something, right? Waves only carry energy, so if you get hit by a wave, you never know it, right? It's not like all of a sudden you turn the lights on in your room and you feel all these little light waves hitting your body, right? Right now, if we were to be able to see all the waves that were in this room, there would be so many waves that we wouldn't actually be able to see out in front of us because you've got what types of waves? Well, everybody always says the first one is water. Sure, water waves. And I said we're going to talk about light and sound. Another one of my personal favorites is the wave, which I'll call like the stadium wave, where you're like, "Whoa!" Remember what it was like to go to a sporting event? I know, it seems like forever ago. Microwaves, ultraviolet, radio, there's a whole bunch of them. Okay, so these waves are carrying energy through space, and like I said, right now there's so many waves that are acting in the room you wouldn't be able to see in front of you because of all the waves if you could see them, but luckily we can't. Okay, so our next question is, well, if waves are energy, how do waves transfer energy? Okay, meaning like if I talk to you, how do you actually hear it? Well, what I'd like you to do is take your fingers and put them on your throat. So you're basically taking your hand like this and you're putting it onto your throat, and I want you to talk. Say something like, "Mrs. McBride is my favorite teacher." Okay? What do you feel when you put your fingers on your throat and talk? Hopefully you are saying that you feel vibrations. Okay? So waves transfer energy through vibrations. The reason why I can make sound is a vibration of my vocal cords. Okay, the reason why I can hear sound is a vibration of my eardrum. Okay, think about like plucking a guitar string. Okay, you can see it vibrate, or hitting a drum, you can see the top of the drum vibrating. Okay, now light, it works a little bit differently, but it's also vibrations. Okay, so vibrations are how waves transfer energy from one thing to another. All right, let's take a second here and we're going to draw a wave. And we'll either draw waves as sine curves or as cosine curves. It doesn't really matter. Okay, and we're going to come back to that because this is telling me to draw a wave and label the parts, but right now we don't know what any of the parts are, so let's start with drawing the wave. Okay, so my plan is that we're going to go through these definitions, and as we define these things, I'm going to go ahead and draw them back on the wave. Hopefully this is a good plan for all of you. All right. First definition. Remember I said there was not a lot of math, but a bunch of vocabulary. So hopefully some of this is vocabulary that you know. First one is a medium. All right, you ready for some bad jokes? What is a medium? It's the size between small and large. Did you know? Okay. How about a medium is somebody who talks to dead people? Still no? Okay. Last but not least, a medium is any solid, liquid, gas, or plasma that waves travel through. So this is a solid, liquid, gas, or plasma that waves travel through. All right. What would the medium be right now that my waves are traveling through? Well, right now, I am in air. Okay, so my waves are traveling through air. Now, waves can also travel through liquid. Think about, water waves or sound waves traveling underwater, or light traveling underwater. Okay, or also through a solid, like right now I was just pounding on my desk. Okay, those waves were traveling through a solid, through my desk, and then also through a gas, through air. So it was going from one medium to another. All right. So some waves need a medium and some waves don't. Okay, so I want you to think about, we're going to talk about sound and also about light. So if we have a solid, liquid, gas, or plasma, that's where we have a medium. Where is there no medium at all? Or where would there be no solid, liquid, gas, or plasma? I heard somebody say outer space, right? In outer space, we say that outer space is a vacuum because there's no solid, liquid, gas, or plasma. So my question to you is, in outer space, can you hear sound and can you see light? So take a second, or what I'm really asking is, do sound waves need a medium? And do light waves need a medium? So take a second and pause the video and think about that. Can you hear sound in space? Can you see light in space? Pause the video. All right, you're back. Let's start with light. Can you see light in space? Yes, if we couldn't see light in space, then we wouldn't be able to see the sun, the stars, the moon, etc., right? So what that's saying is that light does not need a medium to travel, meaning that light will travel through a medium or a vacuum or no medium. So light waves do not need a medium. How about sound waves? Does sound travel through space? In Star Wars, you always hear pew, 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 pow, pow, pow. You're right, great sound effects, I know. So that's what it sounds like when I watch Star Wars. Is that true? I hate to tell you, but it is not, okay? Sound waves do need a medium. So if I screamed in space, it would sound like, did you hear nothing, right? And instead of choom, 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 it would really be, you wouldn't hear anything. And instead of, you would hear, right? Because there is no sound in space. Now, if an astronaut has a spacesuit on and there is air or oxygen inside the spacesuit, then the astronaut would be able to talk. But in terms of space, right? Like if the sun blew up, what would it sound like? It would sound like nothing because there is no sound in space, okay? So every time you watch Star Wars or any of those movies from now on, and they go pew, 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 think about this. Sound needs a medium, and there's no sound in space. All right, let's talk about amplitude. Amplitude is the height of a wave. Okay, so this right here would be its amplitude. Or if you prefer, you could measure from here to here, and this would also be the amplitude. Please note that the amplitude doesn't go from top to bottom, right? It only goes from top to middle or bottom to middle. It's the height of the wave, right? So this wave is the same sort of size as this wave, and that's its amplitude. If we have a sound wave, if I increase the amplitude, what does that sound like? If I have a sound wave and I increase the amplitude, it sounds louder. If I have a light wave and I increase the amplitude, what does that look like? Well, it would be brighter. All right, next one is the wavelength. This definition is crazy. I hope you're sitting down. The wavelength is the length of a wave, hence the name wavelength. Okay, so the way we measure the length of the wave is starting at the same spot. So like a sine wave, we know this is one cycle of the wave. This would be another cycle of the wave. So the wavelength is going from one spot on the wave to the same spot on the next wave, or I like to say that the wavelength goes from top to top, or crest to crest, or trough to trough. Okay, this is the bottom of the wave, or the trough. Think about it like that's where animals eat from, is the trough. And this is the crest, like your favorite toothpaste. Tough crowd today. All right, and again, this is the wavelength when we're going from one spot on the wave a full cycle away, okay? And the wavelength is given by a Greek letter. And this symbol looks like this. I always think that this looks like a coat hanger without the bottom of the coat hanger, okay? And this is the Greek letter lambda. You ready for another bad joke? What do they call a baby sheep? A lamb, duh. Wow, tough crowd. Okay, hopefully you're laughing at home. All right, the units are meters because wave length, it's the length of the wave, so the unit would be measured in meters. All right, now this should be review from when we just talked about the period of a pendulum and the period of an oscillating spring. We know that the period is the length of one cycle, right? We talked about the fact that our class period is 82 minutes, okay? And we said the symbol for period is capital T. And we also said that the units are seconds. And frequency, we said, is the number of cycles per second. And its symbol is lowercase f. And its units are hertz. And now I'm going to want you to abbreviate those as Hz, hertz. Okay, and last but not least, we said period is equal to 1 over frequency, and frequency is equal to 1 over period. All right, let's do one more problem and then we're calling it a day. All right, so what my question to you is, what is the period and frequency of the second hand on the clock? Okay, so if you're thinking about a clock and you're thinking about the second hand, so my question to you is, what is the period, or how long does it take the second hand to make one cycle? Well, hopefully you said 60 seconds, because that's how long it takes for the second hand to go all the way around, or 1 minute, right? And therefore, what would the frequency be, or how many cycles does it make per second? Well, we also know that it makes one cycle in 60 seconds, or we know that those are inverses, right? So we can say that the frequency is 1/60th of a hertz. All right, friends, hopefully you've enjoyed the beginning of waves. We're gonna do a lot more on this particular topic. We're gonna spend the next month or so talking all about light and sound. Have a good day, friends.